So this is the third of the fourth video, again about radical equations. So just jump right into it. The refresher: isolate the radical, square each side of the equation, solve the equation, and check for strenuous solutions. Like I said, the ones in this scenario should be a little bit tougher, so you might actually have to use some more complex uh, quadratic solutions, such as the quadratic formula or things like that. All right, here's your first step. Pause video, work self. We'll go over in a second. Now, we're only actually doing three questions, so this one should be fairly short. So right off the bat, you should see that this first question is kind of a big mess. And you'll see that I barely have a whole lot of time, space to answer this. So you're going to see me doing a lot of skipping of steps. I'll still fill in the blanks of what you're doing. So first thing, we need to get this square root by itself. So we're going to multiply both sides by 4. So if I multiply this by 4, it gets rid of the 4 down here, and this becomes 4x. Now what I can do is I can add 1 to both sides, and I get my radical 6x plus 4 equals 4x plus 1. Now I can square both sides, and I'm going to have to expand this term out. So when I expand it out, it becomes 6x plus 4 equals 16x squared plus 8x plus 1. If you don't see that, you might have to do it by hand, but that's what ends up happening. Again, you double this and you distribute all the terms. Moving the 6x and the 4 over to here, we end up getting 16x squared plus 2x minus 3 equals 0. And then from here, like I said, this one can't be factored as easily as the other one. We can do the different ways of factoring. We could uh, do the setup where we find a term that multiplies to the products, and we separate that middle term and pull and do greatest common factor. But I'm not going to do that. I'm just going to go straight to the solution, the factoring. Again, if you want to do difference, not difference of squares, but completing the square and the quadratic formula, go right ahead. But I'm not going to go into too much detail with that. X should end up being equal to negative 1/2 and 3/8. Again, we have two solutions. We need to see which one's the correct one. So my first step, I'm going to check the negative 1/2. So again, I don't really have a whole lot of room. So 6 times negative 1/2 is negative 3. Again, you can check that out on the calculator. So we get negative 3 plus 4 minus 1 divided by 4. And because it's going to equal to x, it's going to equal to negative 1/2. Doing some math, this becomes square root of 1 minus 1 over 4 time that which should be equal to negative 1/2. However, when you do this, you end up getting 0 up top, which means that the whole left side is 0, and that does not equal to negative 1/2. So what we end up saying is that negative 1/2 is not one of these solutions. So what I can actually do is cross that out over here, because that's not going to be my solution. Now I have to just quickly check 3/8. Again, I'm going straight through it. 6 times 3/8 is actually 9 over 4. So we have 9 over 4 plus 4 minus 1 over 4 equals 3/8. Again, kind of really messy. But from there, when we add 9 over 4 plus 4, we actually get 25 over 4 minus 1 over 4. One thing you should notice is that when you're doing these questions, a lot of the ones that you'll probably see are going to be nice, perfect squares like this, so that you can, again, ideally do a lot of the math in your head. So square root of 25 over 4 ends up being 5 halves. So 5 halves minus 1 over 4 does actually equal 3 halves. You could check that in your calculator, plug it in, and you'll find that it's the same decimal as 3 over 8, which is about 0.375. So again, now we know that 3/8 is a solution. So the negative 1/2 was not, 3/8 is. Down here for number 2, we're going to move the 8 over to the other side to get 6x plus 8. I actually just realized that I probably could have made my life a little bit easier by dividing all the terms by 2. So, uh, you know, could do that if you want. I just squared it instead. So I get 6x plus 8 squared equals 4 times 24x plus 17. Expand out the left-hand side and distribute the 4 to all the terms. So we get 36x squared plus 96x plus 64 equals 96x plus 68. Because we have a 96x in both sides, I can cross them out. And then I'm going to subtract 64 to the other side, and I get 36x squared equals 4. Divide both sides by 36, and you end up getting, so I don't have it here, so I'll just write it a little bit. You end up getting x equals, or x squared equals 4 over 36. When you take the square, which actually simplifies to 1 over 9, and when you take the square root of x, you get plus or minus 1 over 3. So that's where this negative 1/3 comes in. Again, we're going to check our solutions. So let me just erase this real quick. So my first solution, when I plug in the negative 1/3, I end up getting 6 times negative 1/3 equals 2, rad 24, yada, 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 yada. This ends up becoming negative 2 on the left-hand side, and then underneath the radical, this just simplifies to 9. So you get negative 2 equals 2 times 9 minus 8, which ends up getting negative 2 equals negative 2. So negative 1/3 is a solution. Now we check the other one, and this time we're plugging in 1/3. So we get 6 times 1/3, blah, blah, blah. This left-hand side becomes 2. Underneath the radical becomes 25. So we get 2 equals 2 rad 25 minus 8. Square root of 25 is 5. So when we do the math, we actually find that 2 equals 2, which is also a solution. So unlike the other cases, both of these numbers actually do end up being proper solutions to the equations. So again, this is actually why the check is useful. You want to make sure that you plug in both solutions, because you never know, one, if one of them is going to drop out, or two, if none of them end up dropping out, and you end up having both as proper solutions. So you do need to check both. And also in some cases, you might find that none of them, all of them drop out, and that none of them were actual solutions. All right, so here's another application question. So pause the video by yourself, and we'll go over in a second. So once again, this is actually, again, dealing with physics and science, seeing kind of showing you what the equation could, what you can do with these radical equations. So here, this is an equation for escape velocity. So if you want to try and leave a planet, this tells you how fast you have to be going in order to be able to leave the planet. Anything faster than this and you can escape. Anything slower will be stuck on the planet and you won't actually escape. You'll end up falling back down. So this just explains the variables, that this is your escape velocity. This is just some constant value. This is the mass of the planet, and this is the radius of the planet. So here, what they want us to do is solve this equation, moving things around, for the radius. So we're doing the same thing we did with the other question with the pendulum. Because there's really no terms to isolate, we're just going to start off with the squaring of both sides. So the velocity gets squared, and then the square root drops on the right-hand side. Now, because I'm solving for r, what I want to do is do cross multiply. So I end up getting the v squared times r, and then this ends up just being 2gm. Then what I can do is divide both sides by v squared, and I get this, r equals 2gm over v squared. Now, if you wanted to actually save a little bit of time, instead of doing a cross multiply, what I like to do is what I call a cross switch, and just switch these two terms. So it's just like with cross multiply, but again, instead of going through the whole hassle, you just exchange the terms rather than multiply the terms. And you end up getting the same thing, 2gm over v squared. So this is just kind of what you can see if you do end up ever kind of going into science, especially physics, which is very heavy in math. you'll end up seeing some of this type of setup a lot. All right. Again, that's pretty much it. I think in the next video we'll probably see some of the tougher, again, the toughest versions of these uh, radical equations. If you have any other questions, feel free to let me know. Otherwise, good luck and have a great day.